Great to see you here again. My name is Luc de Kuster, founder of the Kuster Academy, and in this video I will talk about the way to find the quadratic formula. We will use the properties of the quadratic equation of the method of completing the square to find the quadratic formula. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time there is a new video, YouTube will inform you about it. When we are talking about finding the quadratic equation, in fact, the goal that we want to reach is to find the roots of any quadratic equation using a simple formula. Now, when we look at the quadratic equation in general, we have it as an equation of the form ax to the square plus bx plus c. And we can write this as a multiplication of the highest order coefficient a with x plus x1 and x plus x2. So this is in fact the factorized form of the quadratic equation. And in this case, we have f of x1 or f of x2 is equal to 0, which means that these are in fact the roots of the quadratic equation. When we want to find the formula, we start from the formula that we used in the method of completing the square. We are going to use the principle of completing the square to find that expression, that special quadratic formula. When you remember, we said that the formula we started with to complete the square is in fact y is x squared plus bx. Now we see that there are some terms missing here, and we have to find a way to transform this equation into a quadratic equation, into a perfect square, basically. Now, a complete square would look like x to the square plus 2ax plus a to the square. So basically that would be a quadratic equation where we have a complete square. Now, when we look at this, we can say we have the term 2a, which in the top of the equation is equal to b. So we can find that a is equal to b divided by 2. So basically we have to add a to the square, and a to the square is b divided by 2 to the square. With this information, we can find the way we can, in fact, complete the square and find a new equation. Now, let's say we do the first transformation. We say that x to the square plus 2 times b divided by 2 times x is a new expression. Basically, they're the same. The only thing I did was dividing b by 2, but in order to keep the equality, I have to multiply b divided by 2 also with 2. So we find x to the square plus 2 times b divided by 2 times x. So that's the first element that we have. In order to make this a complete square, I have to add to both sides b divided by 2 to the square. So let's do that to the left-hand side and to the right-hand side of the equation. We find that the left-hand side, it is equal to y plus b divided by 2 to the square. And the right-hand side is x to the square plus b, 2 times b divided by 2 times x plus b divided by 2 to the square. So basically, since we added the same term to both sides, we conserve the equality. And now we can use the property of a plus b to the square, basically the quadratic or the special product formula for a plus b to the square. And we find the left-hand side is not changed, but now we can replace x squared plus 2 times b divided by 2 times x plus b divided by 2 times to the square. We can replace that by x plus b divided by 2 to the square. So basically, we completed the square and we find an expression at the right-hand side which is a complete square. And we use that to find the roots when we were talking about the method of completing the square. Now we want to find the quadratic formula. And to find the quadratic formula, we will start from the general expression of a quadratic equation, which is a x to the square plus bx plus c equal to 0. And the first thing we do is we divide both sides by a. So we find on the left-hand side a new equation, which is x to the square plus b divided by a times x plus c divided by a. So basically we already see the format that we had before. Certainly the part x squared plus b divided by a times x. And what we do now is we rewrite this in the form x to the square plus 2 times b divided by 2a times x plus c divided by a equal to 0. Now, be careful when we look at the first equation, ax to the square plus bx to the plus c is equal to 0. When we divide by a and we find the other equation, x squared plus b divided by a, x plus c divided by a is equal to 0, those two equations are not equal to each other anymore. And we have to be careful here. But what is basically the same? Those two equations both have the same roots. And we're only interested in the roots. So let's continue with the calculations. Here we have the expression again where we ended on the previous slide. What we're going to do now is to add the coefficients to complete the square, and we are also moving the term c divided by a to the right hand side. In order to do that, first we have to subtract from both sides c divided by a. When we do that, we find at the right hand side x to the square plus 2 times b divided by 2a times x is equal to minus c divided by a. And you see on the left hand side we see basically the same formula or a similar formula that we considered when we were looking at the method of completing the square. Now what we do, we replace or we add the square term, which is b divided by 2a to the square. We do that to both sides, and we find for the left hand side we have x to the square plus 2 divided by 2a times x plus b divided by 2a to the square. And on the left hand side we have minus c divided by a, but we also add b divided by 2a to the square, which is basically b to the square divided by 4a to the square. And we continue with this equation. So here we have the next step, the last step that we had in the previous slide. So what we're going to do now, the left hand side is clearly the side where we can have the complete square, because x to the square plus 2 times b divided by 2a times x plus b divided by 2a to the square is equal to x plus b divided by 2a to the square. And when we bring the right hand side to the same denominator, we see that the denominator of b squared is 4a squared. The denominator of c is a, so we have to multiply c divided by a with 4 times a. So we find the formula on the right hand side, which is b squared minus 4ac divided by 4a to the square. And this again gives us, when we take the root of both sides, we find that x plus b divided by 2a is equal to plus minus the square root of b squared minus 4ac divided by 4a to the square. We have plus minus because basically there are two values of x that will comply with this expression. So that's the next step that we have to do, and from this we can find the final form of the quadratic equation. So here we have that expression x plus b divided by 2a is equal to plus minus the square root of b squared minus 4ac. The first thing we have to do is to add both sides b divided by 2a or minus b divided by 2a, and we can write the square root of b squared minus 4ac divided by 4a to the square. It is also equal to the square root of b squared minus 4ac, and that divided by 2a, because 4a to the square root of that is equal to 2a. Basically, we find the quadratic formula now, and we add x1 and 2, because we can have maximally two roots, x1 and x2. and this value is equal to minus b plus minus square root of b squared minus 4ac divided by 2a. So basically we have here the quadratic formula that is very easy to apply and that we can use very easily in all kinds of software. The other methods we've seen, we have to do the calculations manually, and that's not always possible when we want to program this. There are different ways we can look at this, but the quadratic formula is a very simple formula to use in all our calculations. Now, the next thing to do is to have a look at that quadratic formula, and we have to say that ax to the square plus bx plus c. Then we find the two roots, x1 and x2, which are equal to minus b plus minus square root of b to the square minus 4ac divided by 2a. The term b squared minus 4ac we also call the discriminant, or we call it d, capital D. Now when we look at the discriminant, b squared minus 4ac, we have three cases. The first case is that the discriminant is equal to 0, and then we have two roots. When the discriminant is equal to 0, we have one real root. This means that our expression, our quadratic equation is basically a real square, a complete square. And we have the last case where the discriminant is smaller than 0, which means that there are no real roots. And that's a case that we will discuss later when we will be looking at imaginary roots which contain the complex number I. But that's for another part of the course. Let's have a look at the first example where we have x squared plus 3x plus 2 equal to 0. So we have the coefficients a is 1, b is 3, and c is 2. And we can calculate the discriminant here, b squared minus 4ac, which is in fact 3 to the square minus 4 times 1 times 2 is 9 minus 8, which gives us 1. This means the discriminant is positive, and we have two roots which are equal to minus b plus minus square root of the discriminant divided by 2a. In our case, the discriminant is 1, so we can rewrite the formula very quickly as minus 3 plus minus square root of 1 divided by 2, and we know that the square root of 1 is equal to 1. I typically select x1 as being the smallest root. It doesn't have to be, but it's easy. When I made this assumption or this reference in my courses, it's easy to do some other exercises. I always take the lowest index as being the lowest number. So x1 in our case is minus 3 minus 1 divided by 2 is equal to minus 2. And the second root is minus 3 plus 1 divided by 2 is minus 1. Like I said, some people calculate x1 is minus 3 plus 1 divided by 2, and x2 is minus 3 minus 1 divided by 2 because the plus is higher than the minus. But it doesn't really matter as long as you know which root is which when you are using it later in some other calculations. Another example, x squared plus 2x plus 1 is equal to 0. And here if we have a special case where the discriminant is equal to 0. Discriminant equal to 0, this means that x1 is equal to x2. And when you recognize the special product formula, we can immediately say that this is x plus 1 to the square. Now we found it by calculations, but normally when you see this formula, you should be able to identify that this is really a complete square, and you should not be applying the formula here. Of course, in a computer, it's different. The computer will do the calculation and the necessary conclusions will be drawn in the program. So we have x1 is x2. In this case, is minus b divided by 2a. b is 2, so we have minus 2 divided by 2. a is equal to 1, which means that x1 and x2 are equal to minus 1. So we have those two roots. They're both equal to minus 1. The last case, x squared plus x plus 1 is equal to 0. And here we find that the discriminant is equal to -3. Negative, it means that there are no real roots in this case because the discriminant is smaller than 0. This also means that the quadratic equation does not intersect with the x-axis. And these are things that we have to calculate, that we will use later, because we want to know the roots of the different equations. That was it for the introduction of the quadratic formula, together with some examples. Anyway, before you finish the video, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about this. I thank you very much, and I'm looking forward to seeing you in the next video. Thank you, and bye-bye.